So I can't thank everybody enough for coming. The reality is Sundays are hard talk. At the end of the day, we're all checking out, we're all flying, so it means a whole lot to have you guys here. This talk is Evading Autoruns, as the giant slide alluded to. As for these fools, I'm Kyle Hansloven, a career malware researcher. I spent time both in active duty as well as in the intelligence community. So I've spent that time doing both offense and defense. As a result, we spun out a startup probably about 2 years ago, and Chris is my chief architect there. Both of us have kind of been heavily involved in the InfoSec scene. Chris has been a trainer at Black Hat for years, most recently with his Fuzzing for Vulnerabilities class. And this talk is probably the closest to like, a heartfelt talk or a heartfelt subject that we've kind of spent like careers trying to solve this issue. With that said, it's always important to introduce the problem appropriately. And the problem that we're discussing here is Windows has hundreds, maybe even 1,000, different ways to load different executables and libraries at boot. Sometimes it's when, a user logs in. Another time is just when a specific application launches, like when this application launches, spawn this, essentially dependency. And as a result, that, we have to be able to classify these and call them. And some of the standard verbiage in the industry is to call it an auto start entry point. That's just a way of saying, hey, this is a legitimate application, and I'm going to launch this legitimate application at boot up. So if you think about like Skype, that saves us time from having to log into Skype every time we turn our computer on. As an attacker, thankfully it spawns my implanted system every time I boot up if I'm running as a service as well. So it's kind of got a dual-hatted, purpose. What's hard about that is the enumeration of some of these is extremely hard. If you think about it, Microsoft has MSDN, but at the end of the day, when I mentioned there's hundreds of these, they're not all documented. Many of these are not documented. You'll find them here at places at DerbyCon, or ironically, people of system administrators finding cute workarounds to launch their applications. And unfortunately, attackers know this. They're using indirections specifically to evade the software that's trying to enumerate anything scheduled to automatically start. So hopefully that clearly defines what problem we're trying to solve and what we're poking at here. The go-to tool is sysinternal's suite, and it has the Autoruns tool. This tool is maintained by Mark Russinovich. It's been around, I think it's 15 years or so. It's had code commits to it, and it's undeniably the most comprehensive tool used for this. There's not good metrics online about how frequent it's used, but if you go to like Bleeping Computer, which is not the main download site, the newest version has been downloaded about 300,000 times just since that newest version released. So that's a good indicator that this is heavily prevalent. And that's usually whether you're a system admin, maybe you're a pen tester, or maybe you're just even a software developer trying to figure out how your software's working. With that said, we love Autoruns. I'm a huge fanboy. It's undeniably my favorite tool, and that's saying a lot because I think there's like 11 different tools within the sysinternal suite. I've submitted ideas, bug fixes to Mark for the last couple years, making sure that it keeps up with some of the attacker tradecraft. And it literally inspired us to build our company. With that said, Autoruns is not a tool designed for security perspective, and that might shock some of us in the room because we surely use it for security purposes. It's supposed to just enumerate everything scheduled to automatically start. But because of the usage of people saying, hey, I'm doing digital forensics or something like that, and I need to determine what applications are automatically starting, Mark started adding features like virus total integration to provide us some of that automated detection of what's shady and what's good. And as a result, attackers have gone through great lengths to try to confuse analysts who use Autoruns or bypass the tool in general. So what we're presenting, right, it's just going to be an overview of recent updates to Autoruns, and that's the mundane. Nobody wants to hear that. We're going to go over 4 semi-public techniques. These are techniques that kind of, people have tweeted about, but the reality is not many of us have actually seen it in the wild. And then to get it really exciting, we're going to show 4 private techniques to bypass Autoruns, just to kind of bring some attention to this. Why we're presenting it? Well, attackers are already abusing this in the wild. Right? That's the no-brainer. And as defenders in the room, the reality is we got to be able to up our game. If we're not aware of these techniques and doing some of the offensive research ourselves, we're going to lose. We're always going to be reactive instead of proactive. With that said, I'm going to pass it over to Chris. He's going to begin some of the nested commands portion here.
All right, cool. So nested commands. What are nested commands? So really what we're looking to do here is combine multiple commands into a single persistence mechanism. And we're trying to do this because we want to hide what we're doing maliciously, right? We want to fake out Autoruns. We want to fake out defenders and make them think that we're running some legitimate signed application but really we're just hiding our code in there. So this is kind of the basis for a lot of the things we're going to talk about is indirection and hiding behind legitimate executables. And our prediction is what we've seen so far is that as these detection methods get better, as more people start looking at this, as people start trying to defend against this, you're going to see more complicated nesting, more complex and new indirection strategies. So just get ready for this because it's coming. So when I say we're trying to hide behind some malware, like what am I talking about? What do you mean hide behind some malware? So this is a screenshot of Autoruns. This shows what it looks like if you were to just run Autoruns, right? You get a bunch of stuff. It's going to show you all the things that start up from the mundane, like log on registry keys, drivers, services. It's also going to show you really obscure things like WinSock providers and all kinds of stuff like that. So what we're going to want to do is take advantage of two features that Mark added, and we're going to abuse those for our benefit. So Mark added two features, one called Hide Microsoft Entries and one called Hide Windows Entries. And the point of these features is to help defenders narrow down all of the different things that are running so they can just look at like what's nefarious, right? I don't want to view the things that are signed by Microsoft. I don't want to view the things that are part of the Windows operating system. I just want to see third-party stuff. I just want to see potentially malicious stuff. So how can I narrow that down? And so turning these two options on will hide all of the things. Like we'll hide anything that's signed with a Microsoft cert. We'll hide anything that's defined as part of a Windows operating system. So in this case, we turn those on, and it's really obvious here. We have two things. It's probably hard for you guys to see, but we're persisting command.exe. We're persisting run DLL32, two things that are pretty sketchy, right? So we filtered from tons of noise, got down to what we're really looking for. So before we can talk about how attackers are abusing this, we got to talk about some of the background. So process exit codes. Every process that runs gets a chance to return an exit code, also referred to as a return code, to signal success or failure, right? So an exit code of 0 is considered success. Anything else is considered failure. And you can view these in the shell by looking at the error level environment variable. And we can take these return codes and we can use them to chain execution. So in Bash, we get 3 different operators that we can use to chain execution. The first one is a single ampersand. What this is doing is blocking. So this is saying, I want to run the second command after the first one exits, regardless of whether the first command was success or failure. The second one is a double ampersand. That's if success. So only run the second command if the first command succeeds. And the final one is the double pipe, which is the OR, and that's only run the second command if the first command fails. So as an attacker, they're going to have to figure out, okay, some executable is going to be running, what's its return code, which one of these do I use to make sure that I can chain my execution? So how can we use this to hide behind an existing autorun? So we could find an autorun like this one. This is the VirtualBox tray application. It's just a run key. It points to a binary. That's it. Nothing fancy here. But we can take this and we can turn it into something like this. So we change that command to run command.exe. We're going to point to that application and we're chaining evil.exe. So how exactly does this work? So command.exe/c tells it, Windows, I want you to run the command shell, and /c says everything after this is going to be arguments I want you to run as a command. So then we have start. And what start is going to do is, it's our little magic here. It's going to actually run whatever follows it in a separate process and return immediately. So in this case, it'll run vbox tray app.exe immediately and return. And then, because we chained it with an ampersand, we're going to go ahead and we're going to also run evil.exe. So we're running 2 executables here, right? And the reason we needed start was because vbox tray app never ends. So I told you about all those logical operators and said all of them block, and then some of them run based on whether success or failure. But since vbox tray app will run as long as the OS is running, we have to use the start command to start it as a separate process and background it. So what does this look like in Autoruns? In Autoruns less than 13.80, it would actually show vbox tray app is running. It'll show that the image path is vbox tray app.exe, shows that it's published by Oracle. Only down in the bottom pane does Autoruns betray what's actually happening and show you that it's command.exe that's actually running. So we're good, right? Right? We win? No. Unfortunately, no. So a couple weeks ago, Mark released a new version of Autoruns, 13.80. And we didn't see this in the changelog, but it looks like he silently patched some things. So what changed is that now you can see here, instead of VBox tray app, it's showing that command.exe is what's actually executing. You can look down in the bottom pane and see we didn't change anything, but now it's no longer hidden behind the VBox tray app. So really what did change? Prior to Autoruns 13.80, Autoruns was parsing the command. It found that there was command.exe, it found that there was a /c, and it said, I know what you're trying to do here. I'm going to tell you what's actually running here. This is VBox tray app.exe. So this made hiding malware harder, right? You could no longer hide your malware behind command.exe. It pointed out and said, that was a neat little trick you had there, but no good anymore, right? So it was still possible to hide things, even with this, right? We could use our chaining method, and we could use command.exe/c and point it to some signed Microsoft executable. In this case, I used consent.exe, signed Microsoft executable, comes with Windows, and Autoruns would display, oh yeah, we're running consent.exe, that's signed by Microsoft, so if we're hiding Microsoft binaries, let's just not display that one at all. So September 11th, Autoruns 13.80 was released. And one of the things that wasn't called out in the changelog was that it stopped trying to parse these nested commands. So command.exe/c evil.exe no longer shows up as evil.exe. Now it shows up as command.exe. So it's more obvious now that command.exe is persisting. And really what they were going for here, in my opinion, is to say, this is really an arms race between defenders and attackers. How crazily can we nest things? What kind of indirection can we use, right? And how far was Autoruns going to go? Was it going to try and figure out that there was an ampersand in the command and know that the second thing was executing, right? Then somebody would use some other indirection and we'd be right back to step one. So instead, they said, you know what? We're just going to tell you what the first thing is. If it's command.exe, we're going to tell you it's command.exe. So the downside to this is, as defenders, we now need to have some expert level understanding of what's happening to determine if something is malicious or legitimate. So let's talk about the next technique, shell32.dll indirection. So this technique, malware researcher Hasharazad found this in some malware that she was researching back in April. And what this technique is going to do is it's going to combine run DLL32 and shell32.dll to try and indirect execution and trick Autoruns into thinking one thing is running when something else is. So like I said, prior to Autoruns 13.80, Autoruns would parse run DLL32 and say, haha, I got you, you're actually running shell32.dll, right? So it's changed, and I'll show you what it looks like in a minute, but shell32.dll is actually a DLL that provides a ton of functionality of explorer.exe. If you load it up in IDA or something and go look at the exports, you'll see all kinds of crazy stuff for like popping up open as dialogues, finding executables, running executables. But as an attacker, there are a lot of useful functions in there. Functions like shell exec run DLL and control run DLL, and I can abuse those to redirect execution to something of my liking, right? And the final note here is this is a signed Microsoft binary, so I'm sure you can see where we're going with this. So if we built a command like this, run DLL32, calling shell32.dll, calling the export shell exec run DLL, and pointing at calc, what we'll actually get is run DLL32 will load, loads shell32, calls the export, and ultimately executes our malicious payload. In this case, it's calc. So what does this look like in Autoruns? So prior to 13.80, with no filter on, so we're not filtering Microsoft executables, we're not filtering Windows executables, it would show, hey look, oh, shell32 is being persisted, that was a nice trick. You can see the full command down here in the bottom. But what the problem with this was, and how attackers abused this, was shell32.dll is a signed Microsoft executable. It's listed as part of the Windows operating system. So when you turned on those filters to try and reduce the noise and get to what you wanted, it was gone. right? So it's not always gone. We can turn the filters off and we can find it, but it took away that slight advantage I had by filtering out known good, right? So in the new version of Autoruns, even with MS filter on, it still shows, right? Because we're no longer parsing the run DLL 32 arguments. Now we're just exposing, hey, look, it's run DLL 32. It's right there, okay? So even if we were to turn on filtering, it still shows. So again, just like with command.exe, with run DLL 32, they stopped parsing the arguments. I haven't really dug into Autoruns yet with IDA to figure out if they stopped parsing it altogether or if there's just a limited subset, you know, things like command.exe, run DLL 32. I don't know. They might have stopped it altogether, but it's hard to say. It wasn't in the changelog. So the problem here is that many legitimate applications actually use run DLL 32 to persist, right? I've seen this with like printer drivers, with really terrible like tray icons, right? They just have a DLL and they're using run DLL 32 to actually persist. So again, because of this, you're going to now need some expert level understanding of what's happening to figure out where is execution going and is this legitimate or is this malicious? All right, so the next technique we're going to talk about is DLL hijacking. Anybody ever heard of DLL hijacking before? Yeah, of course, right? Like, this has been around forever, since, like, early days of Windows XP. And basically, this is a technique where, you know, we're going to abuse the Windows search order for how it looks up DLLs in an attempt to load a malicious DLL instead of the legitimate DLL. So, Windows XP Service Pack 2 actually made a change to this. So, prior to Service Pack 2, there was a different ordering in which directories would be searched. Since Service Pack 2, it's been fixed and it hasn't changed. So when we're talking about DLL hijacking and Autoruns, Autoruns only shows you the executable. It doesn't show you these are the DLLs that are going to load. So if someone is actually taking advantage of DLL hijacking, Autoruns can't help you, right? So what is this search order? If the application calls load library, Windows is going to go and look in, you know, the current directory where the application was launched from, system directory, Windows directory. It's going to look in the path. Okay, it's going to look for all of these. And whenever it finds a DLL with the right name, regardless of whatever it is, that's the one that gets loaded. So as a malicious attacker, I'm looking to place my malicious DLL higher in the search order. Because if my DLL is found first, then the legitimate DLL doesn't get loaded. So we've seen this come back, right? This is an old technique. But we've seen this come back, and not just come back as a way to hide malware, but as a way to evade Autoruns. So recently we found this Drydex variant that's going to use DLL hijacking and a technique called atom bombing. And when you look at this in Autoruns, all you see is the executable. So the first thing Drydex does when it's installing itself is it's going to search through System32. It's going to hash every file in there until it finds a file with a matching hash, right? Super common for malware. Then it's going to take that file, that signed, legitimate Microsoft executable that's in System32, and it's going to copy it to the user's profile under app data roaming. It's going to then open that executable up. It's going to look in the import address table. It's going to find one of the imports, and then it's going to copy that DLL from System32 to the same directory in the user's profile. So now in that directory we have our legitimate executable, and we have a malicious DLL where they actually take and inject some payload into it to run their malicious code. And this is a technique that's called atom bombing. It's too complex to go into, but there's a good blog post if you're interested in exactly how this works. So finally, we've got our two files, but now we need to get our execution. So we're going to go ahead and just make a registry key, and we're going to make a shortcut, and we're going to point these to our legitimate executable. And the point is, when the user logs in or when the computer boots, that legitimate executable is going to start, it's going to load its imports, it's going to find the malicious DLL, load the malicious DLL, and now the malicious payload is what's actually executing. So this is a screenshot of what exactly it looks like. You can see our directory, randomly named, under app data roaming, contains two files. One is a signed Microsoft executable, and one is a DLL that has been modified. So if we actually look at this in Autoruns, you can see it shows as being published by Microsoft Corporation. It shows that it's a legitimate executable. And the only thing here that really looks questionable is the path. Also the name of the run key, right? If they'd tried a little bit harder, maybe gone for a little bit less random, it would have been harder to spot. But the problem here is that this is legitimately signed, so it's hard to see. All right, so the next technique, this is Sync AppV Publishing Service. So I searched on the internet, and it looks like Casey was at least the first person to point this out back in April, but I'll defer to him on where that actually came from. So Sync AppV Publishing Server is a PowerShell commandlet for app virtualization publishing. I have no idea what app virtualization publishing is, but it doesn't matter. So the interesting part here is that this commandlet also comes with two other files, a VBS file and an exe. So these are helpers, and the point of these helpers is to allow you to call this PowerShell commandlet from places where you're not in PowerShell, right? Maybe I want to call it from the command line, maybe I want to execute it from a batch script, something like that. What these helpers are going to do is build up that command and actually run PowerShell. So they're going to take arguments from the command line, they're going to format them, and they're going to pass them to the PowerShell module. And this is where it all goes wrong. So let's dig into this. So first thing we got to do is we got to build our PowerShell command. We're going to parse the command line, we're going to store all of our data in the G command args global variable, and then we're going to build up this other variable called sync command, and we're passing in here raw PowerShell. So we're setting up, like, this is the module path. I want you to import the module appv client, and I want you to run the function sync appv publishing server, and then to this string of PowerShell code, they're just going to append what they got from the command line. Okay? Once they have that, they're going to go ahead and build up a command line. So you can see here we're running PowerShell exe, and the attacker's favorite stuff, right? Non-interactive, window hidden. And we're just going to, right there in the command line, we're going to pass all that PowerShell code that we just built up. Okay, so we took command line arguments, put it into PowerShell, put that PowerShell into a command line, and then now we're going to create our WScript shell, and we're going to actually go ahead and run this. And this is the badness, right? So because we're building these as strings, we're doing no escaping, we have no idea what the user could pass. They can actually add raw shell commands to be injected. Theoretically, there's also a command line injection here. Escaping PowerShell is kind of hard. I couldn't really make it do much, too many interesting things. I tried to set it with the window shown just to prove it was working, but it didn't want to. So either way, you can do pretty much anything you want in PowerShell, right? It's pretty Turing complete. So the other thing is, this was the VBS that we were looking at. The exe that comes with it has the exact same vulnerabilities. It does the exact same thing. So in that case, we can just call the exe and pass it something like this from the command line. Period, semicolon, okay? We're terminating that PowerShell command, and it's going to fail. It's going to try to run the sync appv publishing server. That's going to fail, and then it's going to go on and try to run the next command that we've added here, which is start process calc. Okay, we could have made that start process evil.exe, whatever we wanted to. And so what will happen is we'll start up PowerShell, and PowerShell will do our bidding for us and start our malicious payload. So what does this look like in Autoruns? Why is this useful? Sync appv publishing is signed by Microsoft. Okay, so when we look at it in Autoruns, it's going to show like, oh, I'm running this sync appv executable out of System32. It's signed by Microsoft. Down in the bottom pane, that's really the place where Autoruns is going to give you detail. It still shows that we're doing some sketchy stuff there, right? Like that doesn't look normal. But in this case, there's no filter on here. If you were to turn the filter on and filter out Microsoft executables or Windows components, this would disappear again. So with that, I'll turn it over to Kyle for some of the private techniques that we've been finding.
All right, so the easiest one I want to jump into first is a bug that happens when essentially parsing service DLLs, but jumping straight into service DLLs assumes you know what a service is, and that's not a very good way to start. So as a quick overview, I'd want to cover two distinct types of services. The first one is a standalone service, and the iPod service that's installed by default with iTunes is a perfect example of this. It's used for managing hardware, and what it does is within the registry it's set up to run as its own process. Most importantly is when this process gets started, when the service starts running upon boot, it's going to spawn the iPod service binary. That is a standalone service. So within the registry here, we've got a key that's the iPod service. We've got an image path value that's standard within the registry, and it says, hey, this is the binary we're going to launch, iPod service.exe. And then you'll see the type down here at the bottom. It just says hex 10, and hex 10 just means that own service or a standalone service. So nothing crazy there. Within Autoruns, this appropriately shows up as it's the iPod service. The iPod service is digitally signed by the publisher Apple, and it gives all the details in the bottom below, right? Nothing overly exciting. It's a service. As for the next type of service I want to call out is a shared service. So for instance, DCOM is a perfect example of one of these. It's installed by default in Windows. It's set up to actually run as a share process instead. So that would be that same type value that we saw before. And when it spawns, this is what actually spawns SVC hosts. There's a whole bunch of us that look at SVC hosts and we immediately think, oh, it's nasty or malicious. But the reality is it's a serviced host, a process that spawns, and then it loads in a DLL. How it handles this is with a service DLL, and the actual code getting smashed in or injected in or loaded, however you want to look at it, would be the RPCSS DLL. That's how DCOM works. So nothing shady about that. That's normal. And these service DLLs service hosts could have multiple DLLs loaded into them. Within the registry, once again, you get DCOM as the actual key. You get image path this time. It actually says, I'm going to spawn SVC host when the computer boots up, and I want to run it as part of the DCOM group. Once again, there's that type, hex 20, saying it's a shared process. But the distinct difference, and this is key to this bypass here, is it has an extra key, which is the parameters key. The parameters key is what specifies, hey, we have a service DLL, and what actually needs to be loaded is that RPCSS DLL. Jumping into Autoruns, we quickly see that, hey, it shows DCOM, it's a legitimate Microsoft application, but it's done the heavy lifting for us that says, hey, as an analyst, don't worry about SVC host. Focus on the actual payload getting loaded in, because this could have been a malicious attacker loading their own nefarious DLL. However, let's show you the bug, what's going on here. So if we want to do maybe a little bit of tampering, what if we took that same iPod service and now added a parameters key? And within that parameters key, we added a service DLL pointing to an arbitrary DLL. In this case, I took the iPod service and said it actually has a DLL that's for DCOM. Well, within Autoruns, we jump into it, and the iPod service is now not signed by Apple, but signed by Microsoft. So that's a pretty that's a perfect bypass of what we could abuse. And if we look, it actually points to the DLL there. So more specifically, we could create our own malicious service, schedule it to automatically start shady.exe. Even though its type is set to a standalone service, it has a parameters key that we've added, and I just pointed it to a legitimate Microsoft DLL. This time it was a DHCP core library. And voila, we've got our DerbyCon DerbyCon service that's showing up as legitimately signed Microsoft binary. In this case, it was DHCP core DLL, but it really could have been any binary that we wanted to point it to. So that's a pretty legitimate victory there on how to bypass Autoruns. The next one is extension search order. And this is one of those things that it's a crusty old technique that a lot of people don't consider as an issue. And to think about this is kind of like the search order Chris talked about earlier with DLLs, that DLLs have their own way of resolving, hey, where is this actual application? So most of us don't think about, though, how search order really works. Like, for instance, if we just called calc here from the command prompt, where does it find calc? It doesn't know where calc is. So if we were to jump into procmon would walk the stack and it would say, oh, I'm going to try the local directory that you're currently executing from, and then I'm going to walk through several other directories till I resolve that it's really in system32. And how it's doing that is just the good old-fashioned, like the path variable, right? Environment variable that says, hey, walk these directories till you find it. Nothing special about that. But what if you just launch calc? No extension at all. Things get hairier, right? You have to ask, how does Microsoft know that that is actually calc.exe? And it will work. And if we look within procmon, it has all our answers once again. After resolving the actual file extension, the directory of where calc is located, we notice that it starts trying to find file extensions and is, terrible projector up here. But on the slides, I'm showing that it's actually trying to resolve calc.com before calc.exe. And the reason it's doing this is because of the path extension variable. And the reason this is so exciting is the path extension environment variable says, by default, resolve .com files instead of .exe files first. Well, fuck you, little grumpy cat. The point of this thing is file extension search order is super important. And as an application developer, if I accidentally implement the wrong search order, I could return wrong results. So if I want to just reinvent something lame like the run key, say we take the security health run key that ships with Windows Defender. And by default, within Autoruns, it's going to show up as the security health binary, and it resolves the path. There's nothing exciting there. But one of the themes at DerbyCon this year has been how can we weaken some of the hosts to enable maybe non-obvious persistence mechanisms? So what if we just change that from the single binary name, MSASC, etc., and just remove the file extension? And then drop the same file name with a .com file extension as well. Well, the reality is the next time that computer boots up or somebody logs in, we're going to get our payload and we're not going to get the actual Microsoft Defender or Windows Defender security health service. And as for Autoruns, unfortunately, Autoruns resolves exe first. So it ignores the .com that's actually there, and once again, another just fun bypass. So, great example of just small, minor bugs, and how us as defenders, if we're depending on some of these tools for telemetry, we need to be aware of all the subtle differences between the operating system and our actual tools providing us that telemetry. How about SIP hijacking here? So this is anybody who attended the actual opening ceremony keynote, right, with Matt. He covered real quick and said, hey, there's a lot of stuff that we depend on trust. And one of those, he talked about the ability to add components that essentially when we're doing validation of certificates, we could maybe have something nefarious show up as something legitimate, right? So the most abbreviated version of this, of how it could be used to bypass Autoruns, would be I start out with shady.exe. And shady.exe could be a backdoored version of Notepad, for instance. But if I took and I added a stolen authenticode signature that was legitimate and appended it to my binary, in conjunction with Matt's research that said, hey, look, I can actually add this custom component that does bad validation that my certificate is actually valid, that's a big win, because within Autoruns and within the operating system, it says, hey, shady.exe is legitimately signed by Microsoft. Once again, another nasty trick. So within Autoruns, clearly we have backdoored notepad.exe here. But if you look at how these things are hidden in Microsoft's default filters, you're essentially blind. And even at that point, you're going to see, if I use good tradecraft, obviously Notepad persisting is a little odd, but if I started making it anything else that was semi-believable with good tradecraft, that would hide in plain sight. So that's essentially our third private technique that Matt essentially exposed here. And the last one I'm going to get to is INF scriptlets. And this one is near and dear to my heart because scriptlets have been around for a long time. Casey did a great job of exposing this and bringing attention to it last year. And the first thing that comes to all of our minds with scriptlets is regserve32.exe. And regserve32.exe, the reason that it comes to our mind is in Casey's example, we use this legitimate Microsoft executable to essentially say, hey, I want to silently register or unregister an object, a binary. And what he's doing here with this specific command when he released it is it's saying, I want to unregister the scrobj DLL. And when that gets called, essentially it's DLL unregister routine, we'll go and provide essentially a basic framework to pulling down what he called it was a scriptlet, or what Microsoft calls as a scriptlet. It's XML, and the benefit of this is we have a legitimate Microsoft application that calls another legitimate DLL that pulls down a actual payload that could be, somewhere remotely on the internet or locally on the file system, and it will use the native proxy-aware features to pull it down over HTTPS. What more could you ask for in its attacker? And immediately, the media went wild on it. They blew up, and the immediate reaction was, from vendors, was anytime you see regserve32 that's essentially executed, we can't stop it because that has legitimate functionality used by tons of software. But the reality is there's not many legitimate cases for calling scrobj.dll, so they prevent it. And within Autoruns, they followed suit. They said anytime that we see regserve32.dll being used, we want to automatically display this. So regardless of how the filter is set, you're going to see it. So we're safe, right? Everything's good? No, I wouldn't be up here saving this for the last if we were safe. And it all started with just browsing good old-fashioned MSDN. And as I'm working on a project related to drivers, I noticed that these old school crusty INF files have a capability, they call it a directive, called DLL unregister or register DLLs. And under the hood, it says, you know what, if you created, and this is the one that you want to grab the screenshot of, or the picture, if you created yourself a shady INF file, this INF file, when called with the appropriate Microsoft applications, would magically go, and just like the regserve32 example, it would actually take that DLL, pull down your scriptlet, and you've got scriptlets reinvented again with another, vector through INF files. Well, the reality is most people like INF files, you think of like right-clicking and choosing install from the context window, and if you're able to like social engineer your users to right-click and do the context window, you could have just had them run a binary, let's be real. So let's look about how we might be able to find more elegant ways to go about this, right? How about if we use run DLL32, and run DLL32 uses the setup API DLL from Microsoft, and that DLL will actually call the exported function install INF section, which will then load our shady INF file, process that unregister or register directive, and voila, we've got scriptlets reinvented again. So the reason this is so nasty is we start going right back to our autorun scenario. And with autoruns, we see, oh crap, they just updated to 13.8. We're now visible again. Before, it was parsing regserve32 and we would have been hidden, or excuse me, not regserve32, it was parsing run DLL32 and we would have been hidden. So we had to one-up our game right before our presentation. And to one-up our game, what we found natively signed is inf default install.exe. And it will be just as happy to load your shady.inf file for you. And with that said, it will execute your scriptlets. So this really is the last technique we're going to actually publicly expose. We've got a handful of others, mainly related to some printer nastiness. Maybe Casey and I will give a talk on some of that. What's neat about that is it further involves hosts being weakened to the point we almost convinced ourselves we had to prevest through it. So I'll leave it at that. The example is there within Autoruns. Poof, it's gone. And only unless they actually have that filter set up to no longer hide, we will see that our actual binary shows up as the legitimate Microsoft signed executable. And only there in the very bottom do we realize that it's parsing an INF file, doing all the same stuff of the technique that we enjoyed with the squibbly do attack. With that said, I mean, we're kind of at the end of our presentation. Chris, you want to conclude this for us?
Yeah. All right, so conclusion. This is really where we would like give you some mitigations, right? How can you protect yourself as a defender? How can you do something here? Unfortunately, it's not super straightforward. But we didn't want to just leave you and say like, oh, just wait for Mark to make some updates. So we're going to give you something here, something that kind of inspired us. And so hopefully you can use this. So Autoruns not only comes as a UI, but it comes as a console command line utility. So that's autorunsc.exe. It's pretty handy. There's a ton of options you can pass to it. You can give it the -A option and specify exactly what you want to see. Maybe you only want to see when logon stuff. You don't care about services, something like that. You can have it output all of the things that it enumerates in either text, CSV, XML. It'll give you the file hashes. It'll verify digital signatures. You can even give it the option and tell it, hey, query virus total and tell me just straight up, is this known good or is this known bad? So once you have this, you can take and you can build upon this. Remember we said Autoruns is really good at enumeration. It's not so great at security, right? It leaves a lot up to the user. So we can take that and say, all right, now that I've got Autoruns to do my enumeration for me, I can build my detection capabilities on top of that. I can parse what it outputs, and I can determine for myself, is this good or bad? And I can use that to inform my threat hunting. So what are the takeaways from this talk? Like I said, Autoruns is really good at enumeration, but it requires some expert level understanding to really determine legitimate or malicious. And ultimately, in the future going forward, we're going to see more and more complicated versions of nesting and indirection using all kinds of Microsoft signed executables, and really some of the, like Kyle was referring to, archaic features that still exist in Windows that have been there for, since like the Windows 3.1 days. So that's what you can expect to see in the future. So with that, we're done. So thank you for coming. You can reach us if you have any other questions. We're pretty active on Twitter. You can also send us some emails. Hopefully, if not today, by tomorrow, we'll put these slides up somewhere and so you can get them. I know it was hard to read some of the examples, so.
All right. Thank you, everybody. Feel free to come up with questions afterwards.